The purpose of this demonstration is to provide you with a clear example of the power freedom motor and its power generation capabilities. Important to note, the motor you will see in this demonstration is only an example of one scale potential. The power freedom motor can be scaled either larger or smaller, depending on your power requirements. The following is a demonstration of concept. Please focus your attention to the perimeters of this table. Notice that there is no outside power sources present. The only power input used for this demonstration is the 12-volt run battery. Keep in mind that this particular demonstration motor is providing one level of power generation. By increasing the number of coil pods, you can increase the number of power outputs. Additionally, increasing the coil size and/or the input voltage will also increase the output capabilities of the power freedom motor. This reflects the scalability potential of this motor. In a moment, you will see the items indicated on this graph within the video. Each item is clearly labeled to help identify the basic components of this demonstration. Before we proceed, let's run through each item and clarify their relationship with the power freedom motor. First, the power freedom motor. This particular motor is using a 2-coil pod design. The solid-state circuitry provides a pulsing energized control. While there is only one input power source, 2 separate power outputs are created through the 2-coil pods and solid-state circuitry. The 12-volt run battery provides the input power to the motor, giving it the power needed to operate. One of the coil pod's outputs is fed into a charge battery that is connected to the run battery. This provides a continuous self-sustaining power loop. The second coil pod's output is fed into a battery bank of 6 12-volt batteries, which are connected in parallel. This provides an ample power supply needed to perform any type of work. Next, a 750-watt inverter is connected to the battery bank. This will convert the 12-volt DC power of the batteries to 120 volts AC power. The inverter has 2 standard plug receptacles which are connected to 2 100-watt light bulbs. Once the power freedom motor is running, we will turn on each light bulb, demonstrating a working environment similar to those of other alternative power energy systems, such as solar, wind, microhydro, etc. Finally, you will see several multimeters connected throughout the system. These multimeters will be displaying voltage, amperage at individual junctures within the system. As indicated on the graph, we have the basic components that make up this demonstration. Starting, we have the run battery. Currently, the run battery is drawing 12.20 volts DC. Our charge battery, which is also connected to our run battery, is providing 12.56 volts DC. As you can see, the yellow connection is coming from output coil pod 1. The white wire that you see there is coming from coil pod output 2. This is fed to the battery bank, which is currently reading 12.36 volts. In a moment, we are going to turn on the power inverter. As the power inverter comes on, you will see a readout of 0. This indicates the amount of wattage being generated by the inverter. 12.3 is the input voltage that we are getting from our batteries. 120 is the output AC voltage created by the inverter. Next, as we turn on the light bulb, we will produce a draw or working draw from the inverter to the battery bank. As you can see, we are currently drawing 98 watts. Now, as the second bulb is activated, you will see that our wattage draw has increased to 198 watts. Our current draw from the battery is 11.1 volts, and we are still generating 120 volts from the inverter. As we pan over, we can clearly see that our battery bank is at a current draw level of 11.63 volts DC. Our charge battery is maintaining a charge of 12.56 volts DC, and our run battery 12.20 volts DC. The current amperage that we are drawing from this system is 0.45 milliamps. Again, that's 0.45 milliamps. The motor is maintaining a speed of 700 RPM. Again, this demonstration is to provide you with a working environment similar to those of a solar, wind, or micro hydro generation.